This is the EDU sequencer, and a sequencer is one of the tools we can use to control our synthesizer. A 5-step model like this one here is really useful as a sketchpad. We can use it as a way to program little melodies, little arpeggios, or we can just use it as an extra way to add modulation to bigger patches that might be going on. The EDU sequencer has a maximum of 5 steps or stages. Only one step is active at a time, and each step has an LED to let you know when that's the one that's active. For each step, you can set one voltage level with the step level potentiometers, 1 through 5 in the center here, and you can set whether the gate output is going to be on or off with the gate switches, also 1 through 5 to the left-hand side here. The voltages that you've programmed will appear sequentially at the CV output jack, which is this bottom right one here, and the gate pattern that you've programmed will appear at the gate output, which is the next jack up right here. The range of the step level potentiometers is switchable. So we can choose a range of 0 to 5 volts or 0 to 2.5 volts with the switch at the bottom right. The reason for that is that different parameters that we may want to control have different sensitivities. So for example, if we are controlling a VCO via the 1 volt per octave input like we are here, this small potentiometer is going to have a range of 5 octaves, and it's going to be very difficult to dial in a melody that is in tune. 2.5 volt range, which is 2.5 octaves into the 1 volt per octave input, is a lot more reasonable, and you'll be able to dial something in. So the classic sequencer patch is to use it to control a basic subtractive synth voice. So we'll use the CV output right here is going to control the pitch of a oscillator. So the CV output is going to go out to the 1 volt per octave input of this VCO. And the gate output is going to be telling an envelope when to fire, which will be influencing the filter. So with all of the gates off, just listen to the melody droning there. And if we turn the CV, the effect of the envelope up a little bit on the filter and start flipping gates on, we'll start hearing something a little bit more musical. There are 2 input jacks on the sequencer. There is a clock input and there is a reset input. There's a normalized connection from the onboard clock generator that comes through the clock input at the top right. A sequencer is a clocked module, so it's always looking for a periodic pulse or some kind of appropriate signal to tell it when to advance to the next step. Otherwise, it would just be dead in the water. So when nothing's plugged in, there's an onboard clock generator that provides that periodic pulse so that you don't have to have another module just to run this thing. You can change the speed with the rate knob in the top right corner. It goes pretty fast to pretty slow. You can override that internal clock by plugging something into the clock input jack. So if you use what's called a dummy cable, so you're only plugging in one side of the cable, it's going to disconnect that normalization and just freeze the sequencer. And that's really handy when you want to freeze the sequencer and fine-tune a voltage, because otherwise this thing is always free running. So by plugging in a dummy cable, you can freeze the sequencer and fine-tune things. The other reason you'd be plugging something into the clock input would be, of course, you want to control this with a different clock. And you can use lots of stuff in the system for that. You can even use a looping envelope to do it. And the clock also has an output. So there's a clock output jack right here, and that's always going to be a buffered copy of whatever is clocking the module. So when nothing is plugged in, it's going to be a copy of the internal clock, and if something is plugged in there, it's going to be a buffered copy of that. It's a way to daisy chain a clock source through multiple things so you can control everything with the same clock source. The other input is a reset jack, which is this next one right here. Normally, the sequencer advances through the steps until it reaches the maximum step count, which is set by the step count switch in the top left here. The next clock pulse after the maximum step is reached will reset the step count to 1. So with this step count here, let me put that envelope back to being controlled by the sequencer. So with the step count, I can go 3 steps, 4 steps, 5 steps, and that's how I can change how long my sequence is. The reset jack gives us a way to override that count and reset to step 1 whenever we want. So it's a logic input, and it's looking for quite a strong pulse. I think it's probably about 9 volts. So one of the only modules in what I have set up here that can actually activate it is the sequencer itself, and I can show some feedback patching along with the clock output. So I can trigger the envelope with the clock output because I just want it to fire on every step. I will shut off all of the gates, and I'm going to use the gate output fed back into the reset input, and now my gate switches are going to control the length of my sequence. So now I've got 4, 3, and I've got a new one, 2, and I've even got 1. 1 is pretty much useless, but this patch is a lot of fun for setting up some kind of performance stuff because you can jump back and forth between 3 and 5, or 2 and 4, and it's a way to just do something a little bit more dynamic, even though it's only a 5-step sequencer. So now I'm going to take this patch down and show one of the other things that is fun to do with an analog sequencer like this. The EDU sequencer is fully analog, and that often means that it can be clocked really, really fast, which means that we can actually use it to thicken up our VCO. Because we can use our VCO to clock it, the saw output will go into the clock input, and we can listen to our original pulse output by plugging it into the first channel of our mixer. And we are going to listen to the gate outputs in the second channel of our mixer. And I will take the mixer out, is going to go into the filter like this. So this, all we're listening to right now is the original pitch of the oscillator. But we are also driving this sequencer, and because it only advances one stage every time it gets a pulse from the VCO, we can turn every other one off, and if you only are turning something off every other time, that's the same as it being half the frequency. So we can use it as a sub-oscillator by putting the step count to 4 and turning every other gate switch on or off. Now that only works when the step count is 4, because if it's 5, it's going to be counting 1 extra step, which I think that's an octave and a fifth or something. It's some kind of harmony. And we can also do 3 for another one. So anyways, you can play around with different combinations of switches and different step counts and get some new ways to thicken up the sound of your single VCO.